Hey, what's up, guys? Hey, and the chat is working. I think YouTube was having an issue on our last stream because I didn't do anything, and it worked on the podcast with Tony, and it looks like it's working again today. So, what's up, guys? Thanks so much for joining. Today will be a fun one. Lists and tuples. How's everyone doing? All right. Well, might as well. Here, take my face off and we can just do mostly desktop. All right. And there we go. And let's go ahead and pull up Firefox. And we'll go to the guide again, elixirlang.org and guides. So today we are going to be doing lists and tuples. This is a good one. So in this chapter, we'll learn two of the most used collection data types in Elixir, lists and tuples. And they're actually linked lists, and we'll get more into that as we read on. Elixir uses square brackets to specify a list of values. Values can be any type. So let's go ahead and open up our terminal. Oh, wrong window. And I'll make this a little bigger for us. All right, before we move on, in the last stream, for the life of me, I could not remember what this operator was called. I kept calling it a pipe, and I didn't look it up, but it was haunting me, and it randomly popped into my head. This is the cons operator. So I just had to let you guys know. I don't know why I always forget the name cons, but that is what that one is. So Elixir uses square brackets to specify a list, and the values can be any type. So we can start our IEX shell, and we can do something like this. We can do 1, 2, throw a Boolean in there, and 3, and that is a list. And then we can also call built-in functions like length and pass in a list of 3 values, and it will return 3 because there are 3 items in that list. All right, 2 lists can also be concatenated or subtracted using the plus arity2 and minus arity2 operators, respectively. So I guess we would call this, what is this operator called? Concatenation operator for a proper list. Okay, so we can do things like essentially adding 2 lists together and subtracting values from lists as well. So what's happening here is we are appending 4, 5, and 6 to 1, 2, and 3. And then here we're subtracting true and false, and it will take the first values it finds. So this true and this false will be removed. So then we have the 1, 2, and 3. So let's go ahead and pull that up, and we'll play around and try this. So if we do something like 1, 2, 3, close that square bracket, and then go ahead and concatenate these 2 lists together, and we can do 4, 5, and 6. And there we go. Now we have one list, 1 through 6, which is pretty cool. And then let's go ahead and demonstrate the subtraction one. And this example is actually really good because it shows you that it removes the first value that it matches. So we have 1 true, 2 false, and then 3 and true. And then we can subtract with the double minus, and we can have another list with the values true and false. And when we hit enter, we're left with 1, 2, and 3, and the last true of the list. So it's cool to see. Oh, let's see. We got some chats going on. Let's go. Hi, William. I have a live book ready to follow. And you know, I'm guilty. I know live book is really cool and I never use it. So like I have no clue how to use it, but I feel like I should probably start because I think it's a really good way to mess around and learn and code. And I always go to the IEX shell or just create, an EXS file, but I got to start using Livebook because it is pretty cool. And I know so many people that just do proof of concept in Livebook, and it seems like it saves them a lot of time. Hi from Colombia. That's awesome. Hi from Spain. So cool. Hi from Utah. Um, all right. All right. Back to the docs. So list operators never modify the existing list. Concatenating to or removing elements from a list returns a new list. We say that Elixir data structures are immutable. One advantage of immutability is that it leads to clearer code. You can freely pass the data around without the guarantee no one will mutate it in memory. With the guarantee that no one will mutate it in memory, only transform it. So throughout the tutorial, we will talk about the head and tail of a list. The head is the first element of a list, and the tail is the remainder of the list. And they can be retrieved with the functions HD arity of 1 and TL arity of 1. So let's assign a list to a variable and retrieve its head and tail. So this is a very powerful, these are very powerful functions, especially with like recursion and things like that. Whenever you're mapping or looping through a list, head and tail functions are super helpful. So if let's see, we want to just create a variable called list and set it equal to a list of values 1, 2, and 3, and then close those square brackets. And so now we have our list in a variable, and we can call the function head, and it's an arity of 1, so it takes one collection, in our case, our list. And we're going to do this, and it's going to return the head, which is 1. And then if we do the tail, it will return everything but the head. So in our case, it will return 2 and 3 in a list. So getting the head or tail of an empty list, though, will throw an argument error. So if we do head empty, we get an argument error. So the first argument cannot contain an empty list. And sometimes you can create a list and it will return quoted values preceded by the tilde-c. So for example, we could do 11, 12, 13, and it returns tilde-c, and then you see this \v, \f, \r. And what you're seeing here are basically this is ASCII numbers. So it's returning us a string. And we can also, let's see, we can do another example here. So we can do 104, 101, 108, 108, 111. And this is going to return hello. And what this tilde-c means is it's just a char list instead of, so this isn't a string. This is essentially a char list. So char lists are quite common when you're interfacing with existing Erlang code. So when you see the tilde-c, that is a representation of a char list. So it's just a list of characters. All right, back to our documents. All right, so we just talked about our ASCII numbers, and let's see. When Elixir sees a list of printable ASCII numbers, Elixir will print that as a char list. So that's when you saw the tilde-c, and it's quite common. Okay, I already said that. All right, and you can use the I_arity1 to retrieve information about it. All right, so if we use I and then we pass in our char list hello, it will return our term, our data type, a description, and the raw representation. Okay, and then the modules that it lists. Let's go ahead and try that out. I'm going to clear this so it's at the top. So if we go ahead and use the I function for more information, and then tilde-c and pass in our char list of hello. There we go. So the term that we are passing in is tilde-c hello. The data type is a list. The description, this is a list of integers that is printed using the tilde-c sigil syntax defined by the kernel sigil underscore c arity2 macro, because all the integers in it represent a printable ASCII characters. Conventionally, a list of Unicode code points is known as a char list, and a list of ASCII characters is a subset of it. And then the raw representation, which we typed in the Elixir shell already, is a list of numbers. And then the reference of modules is the list module. And then the implemented protocols, it's a collectible and enumerable, iex.info, inspect, list chars, and string chars. So that's pretty cool. And we will talk more about char lists in the binary strings and char list chapter. Let's see when that one shows up. Okay, so we have pattern matching next. So it's in a couple more live streams. We can dive a little deeper. And all right, so in Elixir, you can also use the single quote hello to build char lists, but this notation has been soft deprecated in Elixir version 1.15 and will emit warnings in future versions. Prefer to write the tilde-c or the sigil c, I guess, double quote hello instead. I do like the tilde-c. I think that's a better way to represent it. It makes it a little more clear, because in other languages, you know, you can use single quotes for strings. So I like that a lot better. I think that's a good move. ASCII numbers, what are real world use cases? I mean, I get like everything is ASCII under the hood. So if you have to do any raw manipulation of characters or strings, it's going to break down into ASCII. So I feel like I could probably find a better answer for you, but that is my very broad answer at the moment. And we can Google and discuss this a little more, maybe towards the end of this. Doing hearts with the alt plus num3. Nice, Mike. Multi-language applications. Multi-language for ASCII, yeah, for like accents and things like that, very beneficial. Yeah, because when you throw accents on letters, it's going to be multiple ASCII values. So that's a good point too. All right, tuples. Elixir uses curly brackets to define tuples. Like lists, tuples can hold any value. So if you've written any code, you'll notice like a lot of functions in Elixir will always return like an OK tuple and then the value, or it could be a map, it could be a struct, it could be anything, right? So you'll see like an OK atom to let you know that it was successful, or you might see an error atom as well. And this also helps with like pattern matching. So when you get your expected return value, you can pattern match to the OK atom or like an error atom as well. So tuple is a very helpful collection. And if we go ahead and create our tuple, we'll create our little OK tuple here with a hello string next to it. And there's our tuple. And then you can do things like tuple underscore size, and we can pass in the same tuple, the OK hello. And this will return 2. So there are 2 elements inside of our tuple. Now, tuples store elements contiguously in memory. So this means accessing a tuple element by index or getting the tuple size is a really fast operation, and indexes start from 0. So let's go ahead and create, let's just say tuple, and we'll set a variable here, and we can say equals v12, and all I'm doing is setting it to this value from our IAX line 12. So there we go. So now if I type in tuple, we have it, and I didn't have to retype it, which is like a nice little shortcut, right? But if we use the function element, ELEM, and we pass in our tuple, and then we say we want the value from index 1, we're going to get hello back. And then so if I did 0 here, we'll get our OK atom. And then we can also do our tuple size again and pass in tuple, and we get 2. Pretty nifty. All right. So it's also possible to put an element at a particular index in a tuple with the put_elm arity 3 function. So let's go ahead and go back to our terminal and try this out. So we still have our tuple variable. And now if we say put element and we pass in the tuple and we say at index 1, we want it to say, we want it to be world. And what this is going to do is it's going to replace hello with world. And there we go. But if you notice, the return tuple has world, but if we type in tuple, it's still hello. And that's because the original tuple is stored in our variable and it does not get modified. So just like lists, tuples are also immutable, and every operation on a tuple returns a new tuple. So it never changes the given one. And that is a recurring theme with Elixir, right? Because it's immutable. All right. And then if we lists or tuples, what is the difference between lists and tuples? So lists are stored in memory as linked lists. And this means that each element in a list holds its value, and it has a second value that points to the following element until you reach the end of the list. So you always have the value in the list and then like a memory pointer to the next value in the list, and so on. And so this means assessing the length of a list is a linear operation. And so that means you need to traverse the whole list in order to figure out its size. So the disadvantage of this is you always have to iterate through an entire list to find a value or to know the length or anything. So it can be a performance issue if a list is too long. So the performance of list concatenation depends on the length of the list, of the left-hand list. So like when we did basically right here. So when we added, let's go back up here. When we added this list to this one, we were prepending this to this one. And I might have said appending mistakenly, but we're prepending. So we only had to iterate over our 3 variable list or element list. So ideally, you always want to prepend a list with the shorter values because it'll be more efficient. So like, let's go back to the example that we're about to go through. So like right here, we're going to create a list 1, 2, and 3. And then the fastest way is to just traverse the 0, the list with just one element in it, and prepend it to the list. And then the slower way is to append the list on the back end because we're actually having to iterate through the list to add it to the end, because we don't know where the end of the list is. So we have to iterate over it. And let's go ahead and play around with these examples. So if we have our list, which we already have it stored in a variable, now if we do a new list, like with one element and we just want to prepend it to our existing list, there we go. And we added it. And this is the quick way to do it. And then this is the slow way to do it, where you're adding an element to the end of a list. All right, let me just check on some questions. I am not watching your live, but I love your video content. I will watch this stream maybe on the weekend. Keep doing your good work. Thanks, man. I appreciate that. But you might as well stay and watch. You're here. All right. Okay, back to the docs. You know, when I read docs, I'm a big skimmer, and it's a bad habit because you miss a lot of things. And one thing I'm really enjoying about this is I'm forced to read all the documentation because I feel like, it's like story time where we're all reading documentation together. I enjoy it. Okay, so we just talked about appending and prepending a list. And you have to iterate over the entire list that you're either appending, so the left-hand side. In both cases, you have to iterate over the left-hand side. Hi from Ireland. Oh, that's awesome. I'm glad I'm not the only one. Mike is a skimmer. Stop skimming, Mike. We gotta read the documentation. All right, so tuples, on the other hand, since they're stored contiguously in memory, this means getting a tuple size or accessing an element by index is fast because they're known lengths. We already know how many elements are in a tuple. So updating and adding elements to tuples is a little more expensive because it requires creating a new tuple in memory. All right, so in this case, let's go ahead and get our Elixir shell back up. So if we have a tuple, we're going to create a new tuple because we're going to use their example with a bunch of atoms. So we have A, B, C, and D. Close that tuple. So if we put an element in, like using put elm, and then we pass in our tuple, and we want it to replace index 2, which would be atom C, we're going to replace it with E. Closing parentheses. So when we do this, a new tuple is returned, right? So in a linked list, when you add to the end or the beginning, you're not creating an entire new list because you're linking basically memory allocations. But in a tuple, since it's a fixed size, it requires creating an entire new tuple. All right, so note, however, the elements themselves are not copied. When you update a tuple, all entries are shared between old and the new tuple, except for the entry that has been replaced. This rule applies to most data structures in Elixir. This reduces the amount of memory allocation. Okay, so I kind of said that wrong. Allocation. The language needs to perform and is only possible thanks to the immutable semantics of the language. So the elements themselves are not copied when you update a tuple. All the entries are shared between the old and new tuple, except for the entry that has been replaced. Okay, so we're only really creating a new allocation in memory for C and E here when we manipulate that. So I did say that wrong, and I apologize. So those performance characteristics dictate the usage of those data structures. In a nutshell, lists are used when the number of elements returned may vary. So like I said, you don't ever know the length of a list until you iterate through it. And then tuples have a fixed size. So you have the two, so let's see two examples from the string module. All right, back to the shell. So if we use string.split function and we pass in hello world, we get a list back of the elements split at the space. So we have a list of two strings. And then if we do string.split hello, I need to type beautiful world. You don't realize how much peripheral vision that you use when you're typing until you have a microphone in front of your face. It really cuts down on my accuracy. So when we have 3 words, it then creates a list of 3 elements. And so this is the string.split arity of 1, and then we also have string.split arity 2 function, and this breaks the string into a list of strings on every white space by default. But then you can also use the split at. I think, is this right? String pattern. Oh, sorry guys. The split 2 function breaks. All right, so the arity 2, it takes, I just want to see what we're, split arity 2. I just want to see this documentation really quick. All right, so split divides a string into substring at each Unicode white space. Okay, I feel like the arity 2 is a typo because we're passing in 1 variable, and then the arity 3 one takes our string, the pattern we want to split it at, and then extra options. So that's what I wanted to check, because I was like, why does this say string split arity 2 function? Oh, maybe I just read it wrong. Oh, I got a new subscriber. That's exciting. I forgot that I have notifications that pop up on here. Oh my gosh, Sasha, that's kind of psycho, but I like it at the same time. I don't know. Do you still have the home row bump so you know where to start? I'm assuming you would need to, or you wouldn't know where F and J are. But oh my gosh, I don't know if I could do that. A blank keyboard? Ooh, I don't know, man. I don't know. I don't think I'm skilled enough. That seems like I would have a lot of typos. How long did it take you to be able to type and not correct yourself every second keystroke? All right. So, anyways, back to our back to our split. So I might have just read this wrong. Yeah, I got ahead of myself. So string.split arity 1 automatically splits it at white space. And then string.split arity 2 function breaks it up every white space character since the amount of elements returned in the input. Okay. And then they have split at, where we can split at exact like character input positions. All right, so let's go ahead and do that. All right, so if we have our string, we can do string dot split at, and then we can pass in our hello world string again. And if we pass in 3, I believe it's going to split it at between the L's of hello. Yeah, so there we go. So instead of splitting it at this space, it split it at the, index 3 of our string. So that's kind of cool. And let's see, if we say split at -4, it's going to go backwards. So if we do hello world -4, like instead of thinking like it's not going this way, right? It's going to go from the end of the string -4. And there we go. And it split it at the W and O. All right. Good things to know. All right. It's also very common to use tuples and atoms to create tagged tuples, which is handy which is a handy return value when an operation may succeed or fail. All right. Yeah. So I said this at the beginning. Look at that. I'm ahead of my time. For example, file.read arity1 reads the context of a file with given a path which may or may not exist. It returns tagged tuples. Okay, so file.read, path to file, you either get an OK tuple if it exists and can successfully read it, or you get your error. Good to know. I'm not going to do that because I would just struggle over writing a path right now live. That's just too much pressure. 3 months to go back. Let's see. Try and Hughes DOS keyboard offer one. I did it. It's a nightmare when you do Linux terminal stuff. I can imagine. Typing is not the problem. It's finding the rare characters. Oh yeah, I bet. Because I always forget where the tilde character is, and it's in the top left corner. So if I struggle with that, I'll definitely struggle on a keyboard without any letters. 3 months to go back to my old speed. That's a long time. I'm impressed, man, to stick to it for 3 months. I'd be like frustrated in 2 days and probably get rid of my keyboard. But I mean, that's impressive. At least you know. Come on, Mike, take it easy on me. I mean, I always have to look for it. I don't know why. Like I just have to glance at my keyboard. Yeah, I'm so bad at memorizing things. It's my biggest weakness. But then I just read, I was reading a marketing book the other day, and it quoted Albert Einstein, and he said, don't memorize anything that you can look up. And I relate to that big time because I look up everything. I don't know, the retention, my memory retention, I don't know. I don't know if I broke or if I'm not really good at remembering things. So yeah. I mean, come on. Do I have to hold shift for tilde or is it the back tick? So it's like, that's what I forget. And I just have to see it. And then I'm like, oh, okay. I just type it with a shift. Otherwise it's a back tick. All right. Enough of my rant on the tilde. Okay. I forgot where I was. Okay. If the given path to a read exists, it returns a tuple with the OK atom as the first element and the file contents as the second. Otherwise, it returns a tuple with error and the error description. As we will learn, Elixir allows us to pattern match on tagged tuples and effortlessly handle both success and failure cases. So yeah, so our next live stream will be pattern matching, and pattern matching is probably one of the coolest things with Elixir, and pattern matching responses is amazing. And then also pattern matching for function parameters is really amazing as well. So that'll be a fun chapter. And then so given Elixir consistently follows those rules, the choice between lists and tuples gets clearer as you learn and use the language. Elixir often guides you to do the right thing. For example, there is an elm arity2 function, and you can use that to access the tuple item. And we already used that. So element tuple index 1, we get hello back. So however given, you often don't know the number of elements in a list. There's no built-in equivalent for accessing arbitrary entries in a list apart from its head and tail. So that's true. So Tuples, you can just think as like fixed length things. You know what the elements all should be. And then a list is something you're going to have to iterate through to find the elements that you're looking for. So it makes sense to me. And the more you code, the more things kind of fit into place. I don't really like to use tuples for more than like 3 or 4 elements, because then I think they kind of just get confusing, and you might as well use like a key value list or something like that. But that's personal preference. I guess you could do whatever you want. Like ideally, the shorter a tuple is, the more it makes sense, and at least that's how I feel about it. All right. So size or length. This is a good paragraph. I like this. When counting the elements in a data structure, Elixir also abides by a simple rule. The function is named size if the operation is in constant time. So that means the value is pre-calculated. So that's our tuple. So that's why we used, memory here. I already forgot the name of the function. Scrolling up. Tuple underscore size. So you'll see size for fixed constant time, so fixed length. The value is pre-calculated. So that's when you see size. And then you'll see length if the operation is linear. Calculating the length gets slower as the input grows. So the longer our list gets, the longer it takes. So as a mnemonic, both length and linear start with an L. I like that. So if you see length, you know it's a linear operation because they both start with L. So keep that in mind. That's good. So for example, we have used 4 counting functions so far. Byte underscore size arity1 for the number of bytes in a string. Tuple underscore size arity1 for tuple size. Length arity1 for list length. And string.length arity1 for the number of graphemes in a string. We use byte size to get the number of bytes in a string, which is a cheap operation. Retrieving the number of Unicode graphemes, on the other hand, use string.length arity1, and that may be expensive. And so depending on how long the string is, it has to traverse the entire string. So it's linear. It gets more expensive the longer it is. Now that we are familiar with the basic data types in the language, let's learn important constructs for writing code before we discuss more complex data structures. And that's going to be pattern matching. So pattern matching will be a lot of fun. And that'll be our next live stream. And unfortunately, this is going to be my only live stream this week because I am going to be out of town tomorrow through the end of the week. I'm going to go down to Zion. I have some family coming into town and get some cool hiking in. So it'll be a lot of fun, but I'm a little bummed because I really like these live streams, and I think 2 a week is a lot of fun. And then, then the podcast on Friday where we get really cool and smart people on. So it's been fun, and I love these. Thanks so much for joining, guys. I really appreciate you guys tuning in, asking questions, chatting. And yeah, so that is lists and tuples. You know what? That reminds me. Okay, represent letters, numbers, punctuation. I'm looking up some more use cases for ASCII because I feel like I answered that kind of poorly. All right. Where is it used and why? I want to find a really good. The link between us and computers. That seems good. All right. Why is ASCII important? ASCII is important because it is our link between our computer screen and our computer hard drive. And that link is now the same between all computers. What is ASCII used for? ASCII is used to translate computer text to human text. All computers speak in binary, a series of 0 and 1s. However, just like English and Spanish, can use the same alphabet but have completely different words for similar object. Computers also have their own version. ASCII is used as a method to give all computers the same language, allowing them to share. All right, wait. But as a programmer, efficiency of parsing. That's a good one. All right, what about performance? So efficiency of parsing, ASCII versus Unicode. ASCII characters are only 1 byte. That's why I'm wondering. So like anything that you would convert strings to ASCII if you're manipulating or doing any manipulation to strings or input or form data, right? Yeah. So I think that is a good overall broad approach to what they are. So the next live stream next week on Monday, I tell you it's emojis. That's also true. Emojis. You got to be able to type emojis in your code. I don't know if I might just be talking out of my ass, but I know Swift supports emojis in their emoji form. I don't know if any other languages do, which is kind of funny. I'm sure the other do because it's just ASCII under the hood, right? So next live stream, next live stream will be on Monday, and then I'll try to do another one. I have my Big App Energy podcast on Wednesdays, so we'll probably do the second one on Thursday again. So probably like Mondays and Thursdays. I think that seems to work pretty good. But yeah. All right, guys, this is fun. Thanks so much for tuning in, and I will see you guys in the next live stream. Enjoying the video? Show some love with a like and hit subscribe to stay updated. To support me and keep the content free, click join for memberships or pick up a course at elixirmentor.com and get free access to my private community. Let's jump back in.